All right, in 6.1 part 3, we are going to verify trig identities. Okay, this is very similar to what we've been doing, except now we are going to start with an equation rather than just an expression. Okay, so in this example here, we've got cotangent plus cosecant times secant equals 2 over sine times cosine. So the goal in a problem like this is just to make one side of the equation look like the other. We are going to use all the exact same strategies and properties and theorems and definitions that we have been using, okay? But these problems actually may be a little bit easier because we know exactly what we're working towards. So this is essentially taking a problem that we just did, if we look at the left side of the equation, and saying, here's the answer, get there. Okay, so again, all of the work is the answer. It's really a proof. Okay, so when we do have a quiz or a test on this, it will most definitely be on paper because the work is the answer to the question. So let's start with the left side here and work through and try to simplify and make it look like the right. Generally, you want to start with the more complicated looking side and simplify it to look like the simpler side of the equation. Okay, so here, um, let's try our converting everything to sine and cosine strategy. Okay, my final answer should have sines and cosines, so let's try that one. So I know that cotangent is equal to cosine over sine, and tangent is sine over cosine. And then cosecant is 1 over sine, and secant is 1 over cosine. So these would just be sine times cosine in the denominator like that. Well, now let's try to combine all these. Let's get common denominators and add all these together. My common denominator will be sine times cosine. So if I multiply this term by cosine over cosine, multiply this term by sine over sine, here we'll end up with cosine squared over sine times cosine. Here we'll end up with sine squared over sine times cosine. And then here we'll just still have 1 over sine times cosine. So now I have common denominators. I can just add the numerators together. So just have cosine squared plus sine squared plus 1 over sine times cosine. Well, now in the numerator, hopefully we recognize that cosine squared plus sine squared is one of my Pythagorean identities. That is just equal to 1. So we end up with 1 plus 1 over sine times cosine. And finally, 1 plus 1 is 2. Okay, I guess I should have a trail of equal signs here. Okay, so this is my answer, right? This is what we wanted to get to. So I have shown that the left side of the equation equals the right side. Okay, so again, this is just like what we've been doing, except we know what we want to work towards. Okay, and I guess another small difference is, these aren't always just going to be a single number or single trig function like we've seen before. Okay, we could be working towards some larger expression like we were here. Okay, let's do a few more examples. Okay, in this one, we've got cotangent to the fourth plus cotangent squared equals cotangent squared times cosecant squared. Okay, so our converting everything to sine and cosine strategy worked so well last time. Let's try that again. So cotangent to the fourth would be cosine to the fourth over sine to the fourth. Cotangent squared would be cosine squared over sine squared. Okay, so I'm trying to make the left side look like the right side here. So I'm just working with the left side for now. Let's try to add these together. So we'll need common denominators. So I would need to multiply this one by sine squared over sine squared. So I will end up with cosine to the fourth plus cosine squared times sine squared. And I'm going to go ahead and combine those, right? My common denominator will be sine to the fourth when I add those together. Well, now in my numerator, I can factor out a cosine squared out of each of these terms. So I would have cosine squared times, I would still be left with a cosine squared here, plus I would just be left with sine squared here. And that'll still all be over sine to the fourth. Well, yet again, cosine squared plus sine squared shows up. That is a Pythagorean identity, and that is just equal to 1. So we will just end up with cosine squared over sine to the fourth. Technically, cosine squared times 1, right? But we know that's just cosine squared. Now, this next step might not be immediately obvious, but I can actually split up the denominator into sine squared times sine squared. So what I'm actually going to do here is make this cosine squared over sine squared times 1 over sine squared. Okay, now I can do that because if we think about going backwards, right, cosine squared times 1 is cosine squared, sine squared times sine squared would be sine to the fourth. Okay, so as long as I'm multiplying, I can split up the denominator like that. And now, cosine squared over sine squared would be cotangent squared, and 1 over sine squared would be cosecant squared. And that is what we wanted. Okay? Now, I do actually want to show you a different way to do this. Okay, so this strategy worked, okay, but it was a little bit long. Another option we could have used, we could have factored, okay? In my original problem here, I could have taken a cotangent squared out of both of those terms. So let me do that over here. Right? I'm going to show you a different way to do this. So if I factor a cotangent squared out, I'll have cotangent squared times cotangent squared plus 1. Well, this is one of our Pythagorean identities, right? Cotangent squared plus 1 is just equal to cosecant squared. And we're done, okay? So this was just emphasized that there are multiple ways to do a lot of these problems, okay? So just try something, okay? It may not be the easiest option. You know, my first strategy here, just to change everything to sine and cosine, definitely was not the easiest, but it worked, okay? It eventually worked. So try some of the strategies, and there are multiple ways to do a lot of these problems, okay? Let's do 2 more examples. So on this one, it really doesn't matter which side I start with. They both look equally complicated to work with, right? So I'm going to choose the left. Now, one of our strategies that we talked about was multiplying by a conjugate. So I see 1 plus sign in the denominator. Let's multiply numerator and denominator by the conjugate. So I'm going to multiply numerator and denominator by 1 minus sine of alpha. times cosine of alpha over 1 plus sine of alpha. So, in my numerator, let me write the cosine first. I'm going to leave this factored. So cosine of alpha times 1 minus sine of alpha. In the denominator, if I multiply these out, 1 times 1 is 1. 1 times sine is sine. Negative sine times 1 would be negative sine. So those will cancel, right? Positive sine and negative sine. And then negative sine times positive sine would be negative sine squared. Well, my denominator here is one of my Pythagorean identities. 1 minus sine squared is just equal to cosine squared. So this will end up being cosine of alpha times 1 minus sine of alpha over cosine squared. Now I can cancel out one of these cosines, and I'm left with 1 minus sine of alpha over cosine of alpha. And that is what we wanted, right? So I'm done. This work proves that the left side of the equation is equal to the right side. Now, I could have actually done a very similar process if I would have started with the right side. I could have multiplied the numerator and denominator by 1 plus sine of alpha and come up with something pretty similar to show that this side equals this side, right? So either way would be appropriate here. One final example I want to go through. Secant squared plus cosecant squared equals secant squared times cosecant squared. Okay, kind of an interesting identity. So I'm going to choose to start with the left side, and I'm going to convert these to sine and cosine. So I know that secant is 1 over cosine, so secant squared is 1 over cosine squared. Then cosecant would be 1 over sine. Well, let's get common denominators and add these together. So I would need to multiply this one by cosine squared over sine squared. Oops, sorry, that's not true. Cosine squared over cosine squared, we can only multiply by 1. Then here, I would need to multiply by sine squared over sine squared. So we are going to end up with sine squared of x over sine squared of x times cosine squared of x plus cosine squared of x over sine squared of x cosine squared of x. So now, if I add these together, I can see in my numerator I'm going to have sine squared plus cosine squared. Yet again, that Pythagorean identity shows up. Sine squared plus cosine squared is just going to be equal to 1. Then my denominator, sine squared times cosine squared. Now, I know that 1 over sine squared is just equal to cosecant squared, and I know 1 over cosine squared is equal to secant squared. So I can bring both of those to the numerator. Actually, I'll write this in 2 steps. So sine squared would come up as cosecant squared, and cosine squared would come up as secant squared. Now, technically, right, we wanted to show that this was secant squared times cosecant squared. Okay, so I can just flip those around since I'm multiplying. Okay, and that would be our proof. That would be our verification. Okay, so again, all the same strategies that we've been talking about. Now we are just given what we are working towards, and it may not be a single trig function or a number. Okay, so that is it for this video. The final question is going to pop up asking you what questions you have.